All right. So what is Git? Git is a distributed source control management system. Okay, so not just local to your machine or any particular machine, but distributed source control management system. It means that everyone has their own complete copy of the history. So when you have a Git repo and somebody has access to that repo or clones that repo or forks that repo, at the point that they fork it or clone it, they have access to the complete copy of the history up until that point. Git works with repositories, which you'll hear me refer to as a repo. Again, because it's easier to type and say, and developers are lazy. It has a complete history and version tracking capabilities. And the way that Git works is every change that you make and then commit is bundled in that commit, and that commit captures all the changes that you made with that commit, as well as your account, your GitHub user info, and the date information. So it keeps all of that information with the commit, which is really useful. So why is that useful? Why do we care? When you work on something, unless it's something super tiny, which you'll only do at the very beginning. After that, you'll be working on things that get to be more and more substantial, oftentimes working with other people, but even if you're working alone, okay, even if you're working alone, things get to grow. And another thing that'll happen is you'll get into these sort of feverish states of coding. You know, you're just hacking away at it, having a good time, and then you break everything. It was working, and now it's not working, and you've made so many changes since you last checked that it was all working that you're not sure what you did to break it. So then you try to figure it out, and you start changing more things. Was it this? Let me change this back. Oh, now it's broken in a different way. Okay, it wasn't that. Let me put that back the way it was. Maybe it was this thing. Let me try changing that back. Oh, no, that didn't fix anything. So that can turn into days or weeks of pain and suffering, and Git can help to save you from that to some extent, as long as you use it properly. So if you never do commits, then it won't save you very much. But if you use Git the way that Git is intended to be used, which is you make small changes, test those changes, is a good idea, commit those changes, then every time you commit, you're creating this sort of snapshot. And so you can say, okay, well, at this point, everything was working. I want to go back to that point. It was happier days then. Remember those days when everything was working? And so Git will allow you to roll back to that point in time that everything was working. There are also some really cool tools. I ran across one the other day. I can't remember what it's called. I posted on it in Slack. Do you remember, Matt? It's something that lets you try to isolate where you introduced a bug. So if you've made bunches of commits and you introduced a bug at some point, you're not sure where. It's like this binary search it does for the point. Bisect, yes. Yes. There's this git bisect command that basically you give it the last commit where you know it worked, and you're trying to figure out which one broke it, and it'll take kind of the midpoint between where it worked and now, take the commit in the middle, and then you check that one out and see if it was broken there. And if it was broken there, then you know you need to go back a bit further, so it'll take the midpoint between those two commits, and then you check if it was working there. So it just can speed up the search for the thing that actually broke, the thing that's broken. So there are tools like that available, and lots of cool things available in Git that make it easy for you to get back to a place where the world was nicer and things were better when things go wrong. It also makes it possible for multiple people to work on the same code. So if you don't use version control and everybody just has their own copy of the code and just works on it on their laptop, good luck trying to put that thing back together after everybody's worked on it. You won't be able to. You'd spend days, weeks, months trying to integrate it all back together. So if everyone is working off of a central repository, that's where the code is. you you have a copy of the code on your laptop, you make your small change, then you push that change back up to the central repository so that other people working on the code can pull down the current copy of the code with your change. It's a way to manage that that's a lot more sensible and efficient and productive. If you don't use a source control system and you try to work on code with other people, you are just asking for, I wouldn't even try that. That'd be insanity, pure insanity, I'm telling you. So it's an essential part of writing code. Even if you're just writing code by yourself, it's essential for the ability to go back to a point in time to be able to see what changes you made and when, and sort of pick and choose a point you want to go back to when things go bad. So version control, you might hear it referred to as version control because it's a version of the code. Each commit you can consider a version of that code. It also could be referred to as source control or revision control. So you might hear any of those terms used to refer to what we're talking about here. So look, oh, cute little GitHub guys. They're adorable. All right, so what is GitHub? GitHub is not Git. GitHub is a cloud-based Git system. Okay, there are other ones. There's Bitbucket. There's Git. What's the other? GitHub, Bitbucket. GitLab. Yeah, you'll find that there are a bunch of them that I don't know about. And in this class, we're going to use GitHub. GitHub is pretty popularly used. Bitbucket, probably in my experience, is the second most popular because sometimes it's cheaper than using paid GitHub. So smaller companies might choose to use Bitbucket. If you know how to use one of these, you'll be fine using any of them. Okay. So the challenge with Git is learning how to use Git itself, understanding how it works, knowing the commands and how to use the commands, and understanding the processes and the workflows when you work with Git. That's where the challenge is, and you'll learn how to do that in this class. The tool the system that we'll use in this class will be GitHub. Okay, and GitHub is what's going to allow us to share our work with another person or other people. So you can use Git on your own machine and store in a local repository. Of course, if your hard drive dies, then that's a sad story for you. So you want to use some cloud-based solution with your local Git repository. So you've got a place where you're storing your code that is off of your personal machine. Okay, so even if you're working alone, you don't want to keep it on your local machine. GitHub, I would say, is the platform of choice for open source projects. So most open source projects that are out there, their repos are in GitHub. That's the system they're using. And the last job I had as a developer was at SAP. That was just less than a year ago. And we used GitHub at SAP. So it's popular even for large companies that use Git as a solution for source control. So here's a really cute little cartoon that's pretty accurate probably for a lot of people. So they aren't the same. The terms are often used interchangeably, though. You'll hear people refer to Git when they mean GitHub, and people refer to GitHub when they mean Git. So GitHub is the popular service that extends the Git version control software. It's a distributed system that manages multiple copies of Git repositories, and you can merge them into various branches. You can think of GitHub as a front end to Git. It's one way to think of it. It's not entirely accurate. But you can think of it as a front end to Git with a lot of social features added on top. So not only can you store your code in a GitHub repository, but you can also communicate with other people that you're collaborating with on this source code. You can use it as an issue management tool. People use GitHub to store things other than source code, to do other types of project management, not just for source control. So it's pretty handy little tool. All right, so the meat of things, I think, is understanding, well, two things. One thing is understanding processes and workflows in Git. The second thing is understanding the commands that we use to do those workflows and processes. So in this class, we're going to use the command line interface when we use Git. There are GUI tools. Does everybody know what I mean when I say GUI? Is that a term everybody knows, a graphical user interface? So there are GUI tools. Some of them are super popular. Some of them are really nice. I don't have anything against them, but I think that, and this may be partly from my Unix background and having done everything on the command line for a long time, but I still feel like it's important that people understand how to do things on the command line. Because, well, for a few reasons. One, because maybe you're on somebody else's system and they don't have the GUI tool that you use installed, and so you'd be lost. I don't know how to do it unless I have whichever tool. Also because sometimes GUIs have problems. They just tend to be buggier, than command line interfaces. So if something's not working in a GUI, sometimes it works on the command line. When you do things on the command line, you tend to have a better understanding of fundamentally what's going on, what you're doing. Not necessarily. You could be copying and pasting from Stack Overflow, but there's a higher likelihood that you understand what you're doing when you're using the command line. So, and you can't go wrong understanding the command line. You could use any computer in any job in any team and get done what you have to get done with the command line. It doesn't matter what tools they're using, okay? So in this class, we're going to use the command line to interact with Git. So there is a really good cheat sheet in that link there that you can have a look at. It's also linked in Canvas. We also will print it out at some point and put it up on the wall, but just keep the link to that cheat sheet handy, bookmark it in your favorite bookmarking tool, and you can refer to that anytime. So I really like this cartoon too. This is Git. It tracks collaborative work on projects through a beautiful distributed graph theory tree model. Cool, how do we use it? No idea. Just memorize these shell commands and type them to sync up. If you get errors, save your work elsewhere, delete the project, and download a fresh copy. So that is funny because it's true. So a lot of people, even people who've been developers for a while and using Git, just don't really understand Git very well. And they sort of get by with knowing, I know these commands, and I just do it this way every time without understanding maybe completely what they're doing, or there might be a better way to do it. And then when they just totally hose up their local repo on their machine, they're like, oh, screw it, just delete it, reclone it, and pull it back down, start over. And like that's one of the reasons we use GitHub. So we push everything up there, means that if your local copy goes sour, it's not the end of the world. You can just get rid of it, pull down another one. Or you can go into a new directory. You can keep the one that's screwed up. Maybe you have some changes in there you want to bring over. You can go into just another directory and pull down a fresh copy of the one that's not screwed up. And that's valid. Okay, that's valid. But my aim in this course is to have you be less likely to do that because you know what you're doing. Okay, so and you'll see that it's really valued, and some people will look at you with awe if you actually understand Git really well and know how to use it. So it's a little bit of a power play if you know how to use it well. And it's not magic, it's not rocket science, right? Like anything else, it's just some things you have to learn and then you have to practice. And so we'll have lots of opportunity to do that here. All right, so let's look at some terminology and commands. So we have these four rectangles on here. These 4 boxes indicate sort of different spaces that we've got in Git. So we have our working directory. The working directory is the directory on your device, on your laptop, okay, that contains the source files for this repository. So it's just like from the command line, your pwd, right, shows that you're in the directory where your source files are. It's just the directory where your source files are on your machine. That's the working directory. So you work on files in your working directory, you make changes to them in VS Code, and you save those changes. And then when you're ready to push those changes up, the first step is to move those files from your working directory into staging. Now they still stay in your working directory, but we sort of make a copy of them into this somewhat pseudo place called staging. It's not really a physical place. It's a place that you can't see it directly. You can see it with some Git commands. Don't worry about that too much now, but it's sort of this temporary storage place for changes that you've made in your working directory. And the way that we add changes to that space is with the git add command. So git add command puts changes from your working directory into staging. And then the next step is to push them into another kind of invisible space that you can see with commands called the local repository. So this is a representation of the repository, this tree representation that Git has, that's stored locally still. So far, these first 3 boxes were all still on your machine. Okay? We haven't gone off your machine. You don't have to be connected to a network to run these commands. You're on your machine. And so when we do a git commit, what that does is it creates some metadata about this group of changes that are sitting in staging. So you've made changes in your working directory. You've added those changes to staging. Okay? Whatever changes are in staging, when you say git commit, unless you say specific file names, you can even say specific lines, but I won't show you how to do that because that's madness in my opinion. So when you say git commit, by default it's going to take everything that you've moved to staging and put it into your local repository, wrapped up with this hash value that contains the changes and who made them and when they were made. Okay, so it's this commit is this thing that you can go back to if you want to. So that's committing is the point where we're like creating a save point. That's one way to think of it, you know, in the video game. And you get to a save point. They still have those in video games, don't they? Save points? There's that like ancient?
Yeah.
Okay. So the commit is like your save point, okay? But still, we're still on our local machine though at this point. But we can, once we've done the commit, we could go back to that point later if we wanted to, okay? Now, in order to get things off of our machine onto the cloud, in GitHub for example, or Bitbucket, then we have to do a push. And when we do a push, we take that commit, that bundled set of changes, and we push it out to the remote repository in the cloud. At that point, it's somewhere other than our machine, so if our machine crashes, it's safe. And if other people are collaborating with us, they have access to it. And that's the very basic workflow for Git. Okay, any questions so far? We haven't gone deep yet. We'll go deep to different extents at different points, but this is just at a very high level, understanding that we have these 4 different spaces that we deal with and the commands that take changes from one space to another. Okay? All right. So, when we use GitHub in this class, we're going to use SSH. And the reason we use SSH is to reduce the amount of times we have to type in our password, because we don't like to type in our passwords and we can help it. So in order to use SSH with GitHub, then we have to generate some keys. So even though I've got this -C, don't do exactly what's on here, because I think we can just get away with just doing the first part of this, just SSH-keygen. So I'm going to flip over to a terminal window. Actually, what I'm going to do, well, let's try this. Hang on a sec. What we're going to do to be interactive and awesome, hang on. I'm going to start this Hangout meeting. And I'm going to ask for a volunteer. Volunteer? Make sure I'm in the right place. Okay, who wants to volunteer?
Okay.
All right. All right. So, no, you can stay. We're going to try it this way. So if you go to Slack and go to General, and I just put a Meet link in there.
I've lost my internet.
No. Okay, no. Well, that's okay. Come up here since you volunteered. Come up here. I'll do it. We'll do it that way next time. See, this is the other thing is we won't record it. Bummer. Okay.
Sure.
I'm just thinking about how if it's not done on my machine, then it won't get recorded. Yeah, because I think you're going to need internet. So let's work out why you're not connected to the internet anymore.
Okay.
So, because you shouldn't be on Coder Academy, get on CA Wireless.
Oh, there we go.
Make sure you don't have the proxy turned on. So go to.
That should be.
Yeah. Okay. Cool. All right. You can go have a seat over there, or you can sit here. Sit here next to me. That's cool. Try to go into the Meet link. Admit. Okay. Now, do present now in the Meet. So if you in the Meet link, you should be in there.
Just going up this way.
You don't all have to join. You don't all have to join.
Stop that.
Okay. All right. So try again. Try to join. See if it admit. Okay. Alright. So now, do you present? Alright. Yeah, no. Do it again?
Oh, yeah, good idea.
There you go. Alright. Okay, so now if you open Terminal for me. So you're on a Mac?
I am on a Mac.
Okay, so if you're on Windows, just open your Ubuntu WSL. And let's make your screen a bit bigger, maybe zoom in that terminal
How do I do that?
window. So how do you do that on a Mac? Do you do Command plus?
Yeah.
Oh, there you go. That's good. Okay. All right. Everybody can see that all right? Okay, so first thing you want to do is to CD to your home directory. So CD space tilde. And then that should put you in your home directory. Maybe move your window up a bit so that it's not at the bottom of the screen, so it's easier for them to see in the back. So just, yeah, perfect. Let me do this actually on my end. Hang on. I'm just going to pull this one out. No, pull it out. And, no. Yes, good idea. All right, so in your home directory, you'll type SSH dash Keygen. Who has SSH keys already? Does anybody have SSH keys already? If you do, you don't have to do this. Yeah. If you already have SSH keys generated, don't do this step. Okay? If you don't, okay, so let's do this first. Back up and do ls space .ssh. Yes. Okay, so if you see no such file or directory, you don't have any. If you don't see any keys in there, then you don't have keys generated in your home directory for a user. Okay? So if you don't have keys, then ssh-keygen, enter. And then it's going to prompt you. You're going to just hit enter. We're going to take the default file name, so just enter. And then we're going to hit enter 2 more times because we're not going to put in a passphrase. Just enter, enter, enter. SSH-keygen, enter, then enter, enter, enter. And it'll print out this nice pretty picture.
It's very cool.
The random art image. It's nice. Everybody get there? Okay. Sweet. All right. Now, if you do, so if we want to get a hold, so the way that SSH works is we generate a key pair. If you do an ls on your .ssh, you'll see that there are 2 files there. If you've already been using SSH, you may have another file called known hosts. Okay, but if you haven't used it yet, you'll have an ID_RSA and an ID_RSA.pub. So the one with .pub is the public copy of the key, and the one without it is the private copy of the key. And the way that SSH works is that you take the contents of the public key and you provide it to remote sites that you want to access via SSH. So in GitHub, we'll see that if we go to our settings for a user in GitHub, one of the things that we can do is configure an SSH key, and you can configure multiple keys there. And we will paste in the public key into GitHub, and then whenever we SSH to GitHub, to our user account in GitHub, or to GitHub in general, we SSH to GitHub from our laptop where we have the private copy of this key, it'll look and see, okay, is there a public key there that matches with the private key that I've got here? And if there is, I'll allow this connection to happen. Okay? So it's a method of authentication, a secure method of authentication that prevents us having to type in a password when we connect to a remote machine. All right? So you could, if we had configured a passphrase when we created this key pair, we would still have to type in a password. So that's why we didn't configure it with a passphrase, because I am more concerned with efficiency than security in this case. So it's a personal preference. Some people are super concerned with security and will use passphrases and all other sorts of things. I'm not one of those people. If you are one of those people, that's okay. All right, and sometimes it's appropriate to do that. Yes?
If we did want to set up a passphrase now, would it be possible?
Yeah, so if you were going to set up a passphrase right at this point, you just created the keys and haven't put them anywhere, I would just recreate them. I would just delete the directory and recreate them. I'm sure if we do a man space SSH, let's just try SSH. Yeah, enter. And let's look for, do a // PASS. This is how you search inside of a VI session with, yeah, enter. All right, N for next. And, oh, here we go. Let's see. So passwords and passphrases. No, N for next. N. And, oh, wait. Let's see. K for up. Okay, N for next. So yeah, there might be a way to do it. It'd probably be faster just to Google N for next. I just thought maybe the man page would give us a quick way to see if there's a flag we can pass to create a passphrase on one we've already created. There may not be. I would imagine you'd have to regenerate the keys anyway if you're going to add a passphrase. So, okay, Q for quit. There we go. All right, so now we've generated keys. Now you can use these keys in GitHub, and you can use these keys anywhere else you want to use SSH authentication to reach a local machine. So there may be other cases where you want to use SSH to do that, and you can use the same keys to do that. Now, for those of you who are using Windows, we're going to do one more thing, and that's going to be to copy our SSH keys to our Windows hard drive, because right now they're just in your Ubuntu environment. So, thank you, Matthew. Grab a sticker.
Did I stop presenting?
Yes, stop presenting, and you can leave the Hangout if you want to. And I need somebody who's got Ubuntu. Volunteer with Ubuntu. You don't have to come up here. You can join the Hangout. And then turn off your microphone and present now.
Screen?
Yeah, that's fine. Okay, so if you open your Ubuntu environment, yep, there you go. So what we're going to do is we're just going to copy these keys into your Windows user directory, and this is in case we have to reinstall Ubuntu, which we do sometimes, so we don't have to worry about regenerating our keys and copying them back out to GitHub. We'll just pull them back over from Windows if that happens, and then we'll still be able to use them. So first of all, let's do an ls space /mnt/c. If you have Windows, you need to do this. If you have Mac, you do not. Users / your Windows username /.ssh. .ssh. Yep. So it's a hidden directory. Yep. Enter. And it doesn't exist unless that's, yeah. Okay. Enter. Okay. Just take off the .ssh and make sure that directory is there.
Yeah, that one is good.
Okay, there you go. All right. So now what we're going to do is we're going to do so once you find your directory, make sure there's no .ssh already there, because maybe you generated keys that you're using somewhere from your Windows environment. We don't want to overwrite those. Okay? All right, so now what we're going to do is a CP. Can you make your, can you zoom in? Try Control Plus. Does Control Plus do it? No. Does anybody know how to do that in the Ubuntu shell? I'm not sure. I don't know if it'll let you. Okay, that's all right. We don't have too much to run. So no, just that's all right. Do it clear. Okay, so we're just going to do a CP space -r space .ssh space /mnt/c slash capital U users slash your Windows username slash dot, which just says copy it here. Yep. Enter. Now recall that ls of the .ssh directory, and let's make sure it's there. So that, yeah. Okay. So all we've done there is we've just copied those keys to our Windows drive. Okay. So if we lose our Ubuntu environment or have to reinstall it, we can just pull those keys back over. We don't have to regenerate keys and copy them back out to GitHub, and it just saves us some setup time if we have to do that. All right. So thank you for that. You can stop sharing. You can grab a stick or two. Thanks for that, Leo. I appreciate it. All right. So that gets us past that step. No, we still haven't done anything with our keys, but we're ready to. So we're not going to do this bit just yet. We're going to break for lunch. And who does not have a GitHub account yet? Everybody have a GitHub account? Maybe we'll do this one more step if everybody already has a GitHub account. Yeah, let's do this one more step. So, okay, I'll take another volunteer. It could be anyone, Windows or Mac. Another volunteer to join the Hangout. Rachel, thank you.
What was I supposed to do if the directory didn't exist or didn't access when I...
If you just copied it directly to your home directory, not to .ssh, but just copy -r, just mute it. There you go. Oh, just mute your mic, Rachel. So there'd be a little down here. You click on that. Yep.
And Rachel, if you just mute your mic in the Hangout, there should be in the Hangout space in the meeting. So where you join the meeting? Oh, there you go, there, and then that just stop. Yeah, that one.
After you copy it, your home directory /mouse. SSH space. Just after that, that's fine. Yep, space /MNT. Oh wait, sorry. This just to go in front of that, and put .ssh in front of the slash. .ssh space. Yeah, so you're just copying the .ssh from here to there. Yep. Yep, and then just try that ls again and make sure that you don't get a nested directory. Okay, cool. All right, so the first thing we'll do is from your terminal, like where Rachel is. So if you're on Windows, this will be your Ubuntu terminal, and if you're on Mac, this will just be your terminal. From your home directory, which is where you should be, we're going to do a cat, C-A-T, space, .ssh / ID _ RSA .pub. So we're just going to concatenate, cat just concatenates this file. So enter. And the reason we do this is because cat will display the contents of the file without putting any new lines or anything like that in it. Okay, and that's important. So we're going to copy everything that came out of that cat. So from the bottom up to the SSH. That's it. We're going to copy that. So you might have to right-click copy, or however you do it in your. I think right-click copy should work for everybody. Okay. Now we're going to go to GitHub. And from GitHub, if you go to settings, so that's from your little account drop down, there's a settings, and you go to settings, and then on the left you see SSH and GPG keys. And click the button that says new SSH key. And then for the title you can put like something that refers to your laptop. It doesn't matter what it is. It could be, you know, my Mac or Ubuntu, or just something that lets you know that you're copying in a key from that environment. You can call it foo, it doesn't matter, okay? Just something that so you know what it is. And then paste. And add SSH key. Click the button. It will ask you to put in your GitHub password. When you're adding an SSH key, you're giving your machine a way to authenticate to this repository, so it makes sure that you're the one doing this and it's what you want to do.
Is that weird? Mine didn't know.
Yeah, mine did enough.
It didn't?
No.
Okay. I would expect it to ask.
So what happened?
Oh, it worked. It just didn't ask me to add another, to like add my computer password.
Oh, okay.
I hate when that happens, Rachel.
Sorry.
That's okay. That's all right. Okay, so no worries, Rachel. You can just try again later. Yep, you can check. Perfect. Thank you for that, Rachel. You can. That's okay. That's all right. You can leave the hangout.
Yeah, didn't come up with a password.
Yeah, some people aren't using the password.